Hey everybody, thanks for tuning in. This is Mr. Mott. I'm going to go through how to tackle these type of stoichiometry problems with using proportions. Okay, so I'm looking at this equation. It says C3H8 plus 5O2 yields 3 CO2 and 4 H2O. Now, how an equation differs from a recipe is that there's no units written in. So what we want to recognize as junior chemists here is that the units in the equation are moles. So when we take a look at our equation here, when they don't write the 1 in there, but there are 1 mole C3H8 and 5 moles of O2 combining to make 3 moles of CO2 and 4 moles of H2O. So I would say in the beginning, that's definitely one thing that we want to do right away. The rest we can tackle along the way. So the first question says, how many grams of C3H8 are needed to react with 12 moles of O2? So what we can do just to set this up is that I know I want to find grams of C3H8, and I want to find 12 moles of O2. All right. Next, what we want to do is we want to move the units over, and I'm going to put moles of O2 in the bottom, okay, and then grams of C3H8. Now, if it says moles, we can grab this from the equation. So in essence, everything on the left-hand side comes from the problem. Everything on the right-hand side is going to come from the equation. So for moles of O2, we can see from our recipe that we needed 5 moles of O2, so I can put a 5 down there. Now our equation for grams of C3H8, our equation doesn't give us grams. So what we want to do is we want to find out how many grams are in 1 mole of C3H8. And that's using our molar mass. So now to figure out our molar mass, we want to recognize that in this, in C3H8, that there are 3 C's and 8 H's. So what I would do then is I'm going to go to my periodic table, and we can see that if we were to zoom in here, carbon, it's got a mass of about 12, and hydrogen has a mass of about 1. Okay, and so that's how we're going to figure out our molar mass. Okay. So we said, so we're going to take 3 times my 12 grams from carbon and 8 times my 1 gram for hydrogen. So 3 times 12 is 36 plus 8, 44. So that's 44 grams. Now, just because we're going to be working with this later on, what I would do is multiply that by 1 because there's 1 mole of it. So that's going to be important later on when we're dealing with the other ones that don't have just 1 of them. So there's 44 grams. So what we're really saying after this is that there are 44. It takes 44 grams of C3H8 to make this reaction happen as is. So we're going to take that 44 and we're going to put it right here. Okay. So after that, it's just a matter of cross-multiplying and dividing. So 12 times 44 divided by 5, okay, gives us 105.6, oops, sorry, I'm not on the screen there, grams of C3H8 as our final answer. Okay. So everything's really revolving around the equation. We tackle the next problem. The next problem says how many grams of CO2 are made from 2 moles of C3H8. So we're going to 2 moles C3H8. And again, put your units in and grams of CO2. So it's a similar type of problem. I've got moles on the bottom, so I'm going to go to my equation and find moles. Sorry about that. And so for moles of C3H8 from the equation is 1. And so I'm going to put a 1 on the bottom. And for grams of CO2, again, we want to convert our 3 moles into grams. So I'm going to take 3, I'm going to multiply it by the molar mass, which we'll figure out. And so for carbon, the molar mass is CO2. There's 1 C and there are 2 O's. And the mass of carbon is 12. The mass of oxygen is 16. So that's going to be 32 plus 12 should be 44. So our molar mass of carbon is for carbon dioxide is 44. So we're going to put that here, 44 grams. And 44 times 3 is 132 grams. So this 132, that's what we're going to put in our problem here. In essence, what we're saying from the equation is that for every 1 mole of C3H8, you need 132 grams of CO2. And that's the relationship that we had here. Okay? So now we're going to cross multiply and divide. Okay, so 2 times 132 divided by 1, right? Same thing. And we get 264 grams of CO2. Okay. Our next problem is asking how many grams of H2O are made from 83 grams of C3H8. All right. Put down your units. It's real important that we identify everything. Grams of C3H8, and we have grams of H2O. If you're just writing grams and grams, it's real hard to figure out which numbers should we put in here. And for grams of C3H8, we already figured that out from another problem. Okay, and so we said it was 44. So we're going to put 44 down here at the bottom. And for grams of H2O, we haven't figured out the grams of H2O yet. Okay, so we're going to go back up here, and because hopefully we're going to be experts at molar mass now, you can trust me on this and you can figure it out yourself. There are 4 moles, and the molar mass of H2O is, oh, pardon me, come on hands, 18 grams. Okay, sorry, that's a little hard to read there. Okay, 18 grams. We're going to take 4 times 18, and I think that should be 72. Let's double check. Yeah, that's 72 grams. All right, and so that's what we're going to put down at the bottom, that 72 grams right here. Okay. So we're going to take 83 times 72 divided by 44, and we get about 135 grams of H2O. All right. So that's how we want to approach these problems, and we really only need to do the conversions at the top that we need to. We definitely want to start with write down how many moles you have, because if we don't do that, sometimes we forget what these actually mean. And as we go along, whatever information we need, we can grab it from up top, and we only need to do the calculations that we need to for that problem. Okay? Okay. Looking at the next one, number 4. Okay. It says how many moles of C3H8 are needed to react with 7.2 moles of O2. Okay, so moles of O2, moles of C3H8, and we're just going to get those from the equation again. So looking at our equation, there's 1 mole of C3H8, and for O2 there was 5. So we're going to put 1 on top and 5 on the bottom, and cross multiply and divide, get our answer. So 7.2 times 1 divided by 5, 1.44 moles of C3H8. So in that one, no problems there. And as we go along, you're going to realize that all of these are kind of looking very similar. Okay, so this one we have 10 moles of H2O. Okay, it doesn't matter if we write one on top of the other. So it doesn't matter if you always have your given and your want. So we say how many grams of CO2 are made from 10 moles of H2O. Moles of H2O put our same units. Grams of CO2. And again, we're going to go to our equation. How many moles of H2O were there? There were 4. So we're going to write down a 4 next to that. We want to know how many grams of CO2. We already calculated that as well, so 132. So I put a 4 for the H2O from the moles and 132 grams. And we can cross multiply and divide now. So once you have your grams, your moles converted into grams, it's just a matter of grabbing that information. Okay, so 10 times 132 divided by 4, and we get 330 for our answer. Okay. And number 6 is a moles to moles problem. And so again, that's not going to be too bad for us because we're using the same information from the problem. So how many moles of O2 and our given is 2.5 moles of CO2. Units go across. This should be becoming second nature by now. We go to our equation. How many moles of O2 were there? There were 5. And CO2, there were 3. So I'm going to put 5 moles of O2 and CO2, there are 3. 2.5 times 5 divided by 3, okay, gives us 3. Is that right? That can't be right. Oh, it is not. 2.5 times 5 divided by 3. All right, we get about 4.2 moles of O2. And that's the deal. The only thing I don't think we tackled were how many grams of O2. But you can see the same method applies. And the key thing is, doing all your work up here in the front, labeling your moles first. And if we need to convert to grams, we're going to need to calculate molar mass. So we have to be really good at that. You can check out my other video that I linked on the playlist. And that's that. Hopefully stoic is less of a mystery. Stoichiometry and our toxins unit is less of a mystery now. Thanks for watching.